The first exam question about this topic, this chapter actually, is this one. This is a June 2006 paper 7. And question 5 says this. The random variable x has a probability density function given by f of x equals 4x to the power of k when x is between 0 and 1 and 0 otherwise. K is a positive constant. Show that k equals 3. That's the first part. And then I'll go back over here to see the other sub-questions. Let's take care of this. By the way, this is a very typical question. I'm just going over to the next 3 papers that I got. And as you are going to see, let me just go down over here. You are going to see that the first question is pretty much the same in all of them. Okay? And the way to solve it is also always the same. So you need to show that k is equal to 3. So what do you have to use? You have to use the fact that if you integrate the function for any value of x, that it must be equal to 1 for the reasons that you already understood in our lesson. All right? Now, you have to look at the specificity of the function in this case. It is 0 every time x is outside of 0 and 1. So basically the limits of integration in this case are going to be these. So you have to integrate the function between 0 and 1 and equal it to 1. Just go ahead, integrate that. You know how to do this for a long time. Eventually you are going to have this expression, then solve it for k, and eventually you have the value of k equals 3 as expected. Next question. Show that the mean of x is 0.8 and find the variance of x. The mean of x, you just have to use the formula that you saw in our last lesson. So integral from minus infinite to plus infinite, which in this case is going to be 0 and 1, as you already know, of x times f of x dx. So x times 4x cubed. Now you know that k is 3, so you just plug it over there and solve it. So you just have to integrate it. The limits of integration are 0 and 1. Solve it, and it's going to be 0.8. What about the variance? Just use the formula again. The difference is now that instead of having x, you have x squared over here. So calculate this. Again, the limits of integration are 0 and 1. The expectation you already know, it's 0.8. So you just have to square it. Basically, it's just using the formula. Just go ahead, calculate the things that need to be calculated, and you have the result over there. Find the upper quartile of x. The upper quartile corresponds to the value q for which, this board is crazy today, for which the probability is just 0.25. So I'm talking about the value q over here, the lower limit of integration. The upper limit of integration is going to be the value 1, the maximum it can be, okay? And the area over here needs to be 0.25. We are talking about the upper quartile. That's the last 25%, right? So the area must be equal to 0.25. So just calculate that. And eventually solve it for k eventually, and you'll get the value of k of 0.931. And then you want the interquartile range. For you to get the interquartile range, you already have the one of the values that you need, which is q. Now you need p. And what is p? P is the value for which the area of the function is going to be the first is going to be 0.25, and that corresponds to the area most to the left. So is the integral between 0, the lower possible value for x, and p, for which the function equals to 0.25. All right? Again, calculate this for p, and you have the value of p as 0.7071. Then the interquartile range, as you already know for a long time, is just going to be q minus p. and that's going to correspond to 0.224. Okay? These are always the same, these questions. Let's look at another one. This is June 2008, paper 7, question 7. If Usha is stung by a bee, she always develops an allergic reaction. The time taken in minutes for Usha to develop the reaction can be modeled using the probability density function given by, and here you have it, where k is a constant. First question, again, show that k equals 1 over natural logarithm of 5. What do you have to do? Well, here you have the limits of integration. You just integrate the function between 0 and 4 and equal it to 1 and solve it for k. Let's go there. This board is completely nuts today. Okay, so here you have the function integrated, as I said, between 0 and 4, equal it to 1, and solve it for k, and eventually you have the value of k that you need. Then find the probability that it takes more than 3 minutes for Usha to develop a reaction. So you want the probability that t is bigger than 3. Obviously, it's going to be smaller than 4 because that's the maximum possible value it can be. So that's what you want. What you have to do, you have to integrate between 3 and the maximum possible value, which is 4, the function. Note that now you already know the value of k, so you have to plug it there and solve it. And eventually, the question, the rest of the question is just testing you on your ability to use integrals and logarithms, and eventually you have the value that you are looking for. Then question 3 is asking for the median, I think. Find the median time for Usha to develop a reaction. Yeah. So the median, as we saw in our lesson, is going to correspond to the value of t, for which the area is going to be 0.5. So I picked the lower limit from 0 to m. I could have picked from m to 1, but I use the lower limit. So here are the limits of integration, 0 and m, of the function, equal it to 0.5. Solve it for m until you find the value of m is going to be, it's going to be 1.24 minutes. And that's basically it. Last one, June 2009, paper 7. Question 5. The time in minutes taken by candidates to answer a question in an examination has probability density function given by, and there you have it. Again, k is a constant, show that k equals 1 over 18. So what are you going to do? You are going to integrate this between 3 and 6, equal it to 1, and solve it for k. Let's hope that. Okay. Working fine. Yeah, stay like that. Okay, so integrate the function between 3 and 6, equal it to 1, solve it for k, and k equals 1 over 18. Then find the mean time. You already know what to do as well. Just use the formula. So it's the integral between minus infinite and infinite, which in this case is 3 and 6, of t times f of t. Here, just a detail, this could be the expectation of t, not x. My random variable is t, not x. But anyway, just solve this, and eventually you have this value over here, the mean. Find the probability that a candidate chosen at random takes longer than 5 minutes to answer the question. As you can see, this is the same question as on the previous exam. So you want to calculate the probability that t is bigger than 5 and obviously smaller than 6. So these are going to be the limits of integration of your answer. Integral between 5 and 6 of the function. Solve it, and there you have it. And the last one, I don't think you have to calculate anything. Is the upper quartile of the times greater than 5 minutes equal to 5 minutes or less than 5 minutes? Give a reason for your answer. Well, on the previous question, you calculated the probability that it takes longer than 5 minutes to answer the question. And you got what value? You got 0.148. So 14.8% probability that a random student will take more than 5 minutes. So where is the upper quartile? The upper quartile must be before 5 minutes, right? If in 5 minutes you already only have 14.8, you are looking for the 25% check mark. So this means that the upper quartile of the times must be smaller than 5 minutes, because for 5 minutes you already have a value that is smaller than the 0.25 that you are looking for.